Welcome to The Inevitable, a podcast by MotorTrend.
Hi there, and welcome to The Inevitable. This is MotorTrend's podcast. It's our podcast about the future of the car, the future of transportation, the future of mobility. And boy, do we have a great guest for you today. It's former colleague of mine and a friend, Sam Abeulsamid. He is an industry analyst. But before we get to Sam, my co-host, Ed Lowe, he's got a message just for you.
The Inevitable Vodcast is brought to you by the all-electric Nissan Ariya, inspired by the future, designed for the now. And right now, we have a question. It comes from Instagrammer by the name of @GrinderTV, Brian Goudy, G-O-U-D-E.
Could be Hootie.
Says, I listen to a lot of podcasts, but I do not think I've ever heard anyone from the actual EPA be interviewed. Is this something they shy away from? They're the ones guiding us through all of these changes, finding some shops, people, etc.
What a great question.
Is there a way to have a representative on the show? And indeed, a great question. And I will just say that we have tried having people from government agencies on. We tried to get Missy Cummings when she was working for, I think it was NHTSA or DOT. Yeah. She was a huge critic of Elon about autonomy. And it was just hard. It was hard. There was some red tape.
And it's like, hey, could you fly a bureaucrat out to Beverly Hills to hang out with guys from a car magazine? And it's
we don't do Zoom recordings, which puts us at a huge disadvantage. But we feel it's worth it to have the conversation live and in person. So it's hard to get those folks out here, but we will take it into consideration. And also let you know that we do have. I'm excited to share that we have somebody coming from the California Independent Service Operators, basically the grid folks out here. We're going to get a guy in to talk about a topic on a lot of people's minds, which is whether the grid can withstand all of the electrification of vehicles that's coming and some of the cool things that the California grid has been doing. So it's not quite the EPA. Yeah. It's actually not even close, but we'll take it into consideration. Thank you for your question, Brian.
Let's make a plea now. If you're from the EPA and listening, contact us, MotorTrend at MotorTrend.com, or my Instagram, Ed's Instagram, if you have any other questions or just want to be on our show. We'd love to have him on, but let's talk about Sammy.
Yes, so Sam, he former journalist.
Engineer,
mechanical engineer from Kettering University. A lot of time on both sides, and all sides, and not just working at Ford and General Motors on the PR side, working on the supplier side. Did a stint as a journalist, and now works for a consultancy that really covers the future of energy usage, inclusive of transportation.
Called Guidehouse Insights.
Guidehouse Insights. Sam is the principal for basically transportation.
Principal Analyst. Yeah.
And he's got a lot of stuff. In fact, we ran out of time before we ran out of topics. But as you'll hear, some really unique insights into where this is all going.
And just to back up what Ed said, it wasn't that we ran out of time before we ran out of topics. We got to like 3 of 5,000 things we could have asked him about. Yep. And we're definitely having him back. But before we have him back, here is Sam Abeulsamid. All right, we're sitting here with Sam Abeulsamid, an analyst for Guidehouse
Insights.
And you are Principal Analyst is the job title?
That's what they tell me, yeah.
Which sounds very highfalutin. But you and I used to work together back in 2007?
Yeah, I mean, you were at Autoblog for a little while, but but before that, you and I were kind of on opposite sides. You were at Jalopnik, I was at Autoblog.
That's true, and there was some weird, actually, the real early history of the car interwebs. It was great. We liked each other until Spinelli retired, and then it got very stupidly for no reason.
There was some other editor in chief at Jalopnik, and things got weird.
It got really weird. But then I left promptly and went to Autoblog, and it was much more fun.
Yeah. But now you work as an analyst, but you've had a lot of experience on both sides of sort of new digital automotive media, and then you did some PR work for Ford and GM.
I forgot about that.
Yeah. And now
I had to do my stint on the dark side just to learn how the sausage was made.
I mean, Angus, who hired the both of us, he did Ford PR, and he always told me, like, man, if you really want to know the automotive industry, go work for PR.
Right. But now you're kind of leading the charge on covering a lot of the new transition to electrification. Is that correct? And inclusive of, I would say software-defined vehicles is bigger than electrification, right? It's the switch to digital car is going to be foundational, and it's the biggest sea change out there. I keep telling people, but why don't you? Can you speak on it? How do you contextualize what you do at Guidehouse for like the layperson, the person who's sort of casually interested in cars?
We're at a cocktail party. It's your wife's friends. What do you do?
So, Guidehouse Insights is the market research arm of Guidehouse Consulting's Energy Sustainability Infrastructure Group. So, Guidehouse Consulting's a huge global consulting firm. They're in a bunch of different areas. ES&I is the part. We're part of that. We're a very small part of that, but we play an important role in the company. So, Guidehouse works with companies, governments, with investors, all kinds of different people providing services. And then as Insights, we do market research. And so kind of on the consulting, the way it works, kind of consulting works with clients on execution of plans. We work with them to help develop the strategy before they get to the execution stage. So
This is what you should do.
Yeah, we do market forecasting of emerging technologies. I lead the transportation and mobility team, but we also do things in built environment, DER, distributed energy resources, all kinds of things. It mostly has some relevance to energy use and the energy transformation.
Okay. Which is why when I looked up Guidehouse and looked up what I think some of the reports you've recently put out there, you're covering everything from electric buses to battery swapping, but not for cars, but for like scooters.
We've done for cars as well. Okay.
Well, let's talk about that. Let's get into some how you see the world type conversation. So you talked to we were just at Pebble Beach, and I spent a lot of time at the fire pits at Spanish Bay, smoking cigars and talking shop. And it's a really nice guy, and he's like, EV. He's like, well, how long is the battery gonna last? And I'm like, well, as far as I figure, indefinitely. But life of the vehicle. He's like, I thought you had to it was $10,000 every year, or whatever, whatever the misinformation is.
I'm sorry, who is this knucklehead you were talking to?
Really nice guy.
That doesn't mean he's not
He owns
misinformed.
bad boy bail bonds.
Okay, let me rephrase Johnny's question into one that we asked Rivian CEO RJ Scarinch. Are EVs, in your mind, inevitable for the average consumer?
Absolutely.
Yeah.
To what Jonny was saying, about battery lifespan, I think most people have a misconception about how long batteries are going to last in a vehicle, because even though there are similarities in the technology in terms of chemistry and stuff between the batteries in that laptop or in phone and what's in an EV, there's also some fundamental architectural differences. In our devices that we carry around, because they have to be extremely optimized for weight and size, the batteries basically have no thermal management system. And what tends to happen, if you've picked up your laptop or your phone after it's been charging well, it usually feels a little warm. And heat, excess heat and batteries, very bad mix. That's one of the key things that causes batteries to start to degrade. And that's why, usually your phone after 2, 3, 4 years tops, same with your laptop, the battery won't hold a charge the same way it did when you took it out of the box.
Mine's 3 months, but it's also why you shouldn't. It sucks if you don't have a home charger, but you don't want to constantly be charging to 100% because as you fill up everything, it gets hotter and you start to.
That's when the bad stuff happens.
Yeah, so and if you can charge to 75% or whatever, it's much better for the long term of the battery.
Yeah, and in EV, you've got a much larger battery, and automakers, with one very notable exception, have been very careful about making sure that they can manage the temperature of the battery to try to prevent it from overheating or getting too cold, for that matter. And so what we have found, even though early on, if you go back to 2009, 2010, there was a lot of concern that batteries might last 6, 8 years. What we're actually finding is that the degradation of a lot of these EVs, even after a decade of use, is pretty minimal, like less than 10%
Right.
loss of capacity.
There was that report with Model S. It was like 90 on average was 92% of the capacity was there after a decade.
Right.
Which is
Yeah,
pretty
we'd
good.
be hearing about it, right? I mean, Tesla Model S came out in 2012 as a 2013 model, so we are over 10 years' time. And if we were seeing batteries fail, like at any kind of
you hear
measurable-
about it.
you'd hear about it. It would be news, right?
Yeah.
So okay, so interesting. You went immediately to the thermal
wait,
management
real
piece.
quick, who is the one notable exception?
The Nissan Leaf.
Oh,
because
right,
Nissan was targeting a much lower price point than what
Right.
Tesla did when they launched.
Right.
And so the Leaf has an air-cooled battery. So, and especially the first few years, they've improved the air cooling system, but the first few years of Leafs, if you pick up one of those now, you can get them really cheap because their capacity is reduced so much that you might get 30, 35 miles of range out of it if you're lucky.
Let me go back because you said absolutely EVs are inevitable, and you immediately went into thermal management. But can you, in a kind of lightning round manner, address some of the major concerns that people have? Like, because I'll be honest, yes, I literally drove back from Pebble Beach yesterday in a Ford F-150 Lightning, which I love. I love in the city, but one of my reasons for driving it up there was Ford CEO Jim Farley last year did a road trip with his son, and famously, like, his son was like razzing him because the charging experience was so terrible. This was pre NACS, pre Tesla superchargers opening up to Ford. So I took the truck up with an NACS adapter with the intention of at least replicating part of the trip, and long story short, it sucked. Like we still had problems.
Really?
Oh yeah. Like finding the Tesla, we charged it to the Harris Ranch Tesla supercharger station. It was fine. Like it worked. We pulled up. We were the only non-Tesla there. I didn't get. I mean, I think my peak charge speed I think it was like 90 kilowatt. But I think it went to like 120 when I started, which was fine. But then most of the time it was 91 kilowatt, charging rate, which is not great. And then, but leaving Monterey yesterday was horrible. Like, there's so little infrastructure in Monterey. That Electrify America charging station at the Safeway.
That's
4 stations,
again,
only one working.
That should be in a museum of
but
bad
there's no
infrastructure.
other place to go. And even I actually visited some of the local Tesla places. None of them are open to NACS yet, right? So
let me ask you a question. Does the Ford tell you which chargers
that's
you
another.
can use?
That's another. It does kind of, but you're not quite as. You're just like, do I risk it? It shows me that it's there, but I don't know whether it'll take it. And then, all the guys said download PlugShare. So I had the PlugShare app, so I'm like cross-referencing. And then I got Google Maps because I don't really trust the Ford navigation.
Wow.
It was.
So you just don't like the Ford? Because I did that similar-ish. I went up to San Luis Obispo. Rivian, the native Rivian nav tells you exactly which ones you can use.
It's a little tricky.
Yeah,
Anyways,
well, Rivian's got, they bought a better route planner.
Yes.
And they've integrated that. So that helps a lot.
Yeah.
But I'm now, because I've been pro Lightning as an in-town car. A road trip, it wasn't bad. It actually got better as we progressed. But and this is first world California, earliest of the early adopters, and arguably the best infrastructure in the country. And we still have challenges on road trips between, major population centers. What do you tell people who are deeply skeptical?
As I'm sure you guys do, based on what we do, we get a lot of questions about what car should I buy. And the first thing I always do when I get that question is I ask people, what are you going to use it for? Where you live? How are you going to use the vehicle? And that's one of the keys, especially for EVs, is understanding how people are going to use the vehicle. Mm-hmm. If somebody is buying a truck to tow their horse trailer between here and Monterey, every month or something, or drive across country with a camper trailer, I said, don't buy a Lightning. It's not the right vehicle for you today. Right. But if you look at the way most people use their vehicles, most drivers use their vehicles, somewhere between 80 and 90% of daily driving is less than 40 miles a day. And pretty much every EV on the market, the vast majority of EVs that are available for sale today give you well over 200, in most cases 300 or more miles of electric driving range, which means that even in worst case conditions, if you live in Minnesota in the wintertime, where in wintertime, because you're running heaters and things like that, you're going to lose range. You still have plenty of range for what most people actually use, not what they think they're going to use, but what they actually use. And if people actually spent more time thinking about how do I really use my car or my truck or my SUV, they would come to the realization that, yeah, I can actually get away with a lot less than what I thought I needed.
Right.
Yeah.
And yes, we've come to that. We've come to that conclusion too. Johnny likes to tell the story how the first time you get an EV, you're charging it every night, and then
every minute. That's
right. And then it's like once a week. And then,
this is what some Tesla engineers told us was like, the first week. And this is back in 2013. First week of Tesla ownership, you just drove to chargers. That's all they did. Just drove to. A charger.
You're always looking for opportunistic charging.
Had to be at 100%. Had to be at 100%. And then second week. You just plugged in every night when you got home, and then by the third week, it's like you plugged in when the battery was low.
Yeah,
and that's how.
As an example, a few weeks ago, my wife and I were on vacation in Sonoma, and when you drive a couple of miles west of Santa Rosa, so you get a couple of miles west of the 101 in Northern California, there's no cell service and there's no charging infrastructure at all. And we were driving an EV, and we stopped off at a station in Santa Rosa before we headed west towards the coast. And I topped off the EV, and I did not plug it in again for another 5 days, even though we were driving all over the place around,
but
around
you had
that area.
Big battery, big range, EQS.
Yeah, well, it was a 300-mile range on that vehicle.
Okay, that's it's big range.
Yeah, and even when I finally did plug it in after 5 days, I still had 35% state of charge in that thing. So, I think people vastly overestimate what they actually need. But one other thing, to what you're talking about, with superchargers, on your trip back from Monterey, with some of the charging infrastructure, even though California's got the most charging infrastructure of anywhere in the country, in some ways, it's kind of analogous to the way the wireless cell phone networks developed in the in the 90s and early 2000s. The U.S. was the first to deploy this stuff, and we had a lot of analog charging networks. Plus, we also had very robust landline network in those days. But you go to a lot of other parts of the world that came along a few years later,
like Africa,
and other regions. Yeah. And when they finally started deploying, they skipped right over that first generation, went to digital wireless networks. Here, a lot of it, you'll find a lot of, for example, a lot of the early supercharger stations in California are still the older version 2 stations, which are not going to support the non-Tesla EVs. And I think that's probably what you were finding. And so, a lot of that older infrastructure is going to need to be upgraded along with the expansion that we're doing.
But isn't it also that, because I think I've been thinking about my own journey, and I'm definitely not part of the early adopter phase personally, because if I was, I would have already owned an EV in that sort of 2012 to 2018, 19, time frame, right? And I think that first wave of early adopters, they were more patient, they were more willing to deal with some of the frustrations about finding a charger, or or if you're a Tesla person, you actually didn't have a lot of that because their supercharging network was so good. Now that I'm part of this second wave, which is the bigger part of the curve, right? The adoption curve hopefully is going to be like this, and everybody is, all of these people say, let me try this EV. I know I'm less accepting of it. I kept thinking as I was driving down, like, man, we'd be home by now if I had a gas vehicle, because I would have just filled it up, and it would have been. I don't have to make. I essentially made 3 stops, charged it up to 80% before leaving, and then I made 2 quick stops on the way back per the direction of the Ford navigation. Now, the last charging stop was fine. It was 20 minutes at a 350, which was great, and I made it home with like 60 miles, so it was totally doable. But what do you tell people who are like, I don't know, so I hear you, I have to probably consider a home charger. These things are too expensive. Are we going to see that's actually the biggest one, right? That the EVs are only for the rich. Mm-hmm. Where are we? Why aren't there more $35,000 EVs?
Good question, Ed. Good question.
Clearly, in the early stages of this, the cost of manufacturing an EV is more than the cost of manufacturing an equivalent internal combustion vehicle. And I think what happened was a lot of automakers, they looked at that and said, instead of trying to focus on lower margin segments, we're going to produce, higher margin, more expensive vehicles where we can, either at least break even, if not maybe make a profit on some of these vehicles. And those customers that are buying those, they're more likely to go for something new. They're more likely to be early adopters. They're also going to be more likely to have other vehicles in their household so that they can utilize. And what we ended up with was too many companies targeting the premium segments, more so than there was demand for those vehicles. And, so you end up with $90,000 Lightnings and Silverados and a lot of other stuff. And, it saturated that market. And only then did they start looking, okay, now we need to do more affordable EVs. Because they hadn't yet figured out how to make those more affordable EVs in a way that they could actually make money on it to be profitable. The battery costs are continuing to decline. They're figuring out new manufacturing methods for the vehicle structure itself to take cost out. They're taking cost out of the electrical and electronic architecture of the vehicles. And doing other things to reduce the bill of materials cost of the vehicle, so that they can start to offer these more affordable vehicles at price points that average consumers will buy, and hopefully we'll see those. I think we're going to start seeing more of those coming to market over the next couple of years. In particular, I mean, we've got stuff like the Kia EV3, EV4. I'm sure there'll be Hyundai equivalents. Ford, has their Skunk Works program here in California, trying to develop something in that area. And I think we'll finally start to see that.
But okay, so and it was a bit dorky looking, perhaps, but GM did have the Bolt for a long time, and that was a low price point. I mean, after the $7,500. You were in the 20s for a while. Like what that never took off. What was why not?
Well, the challenge with the Bolt. I mean, I love the Bolt. I think it was a fantastic car.
Car of the
but
year. We named it Car of the year a decade ago.
2017.
It arrived in the marketplace, in a form factor that the timing was wrong.
Right.
If you had launched a car like the Bolt in 2010, 2011, which unfortunately at that point the technology wasn't at a point where you could have that car at that 250 plus mile range in that time frame. But by the time it arrived, the overall market was well on its way to abandoning small cars and going to small mid-sized crossovers. And if the Bolt had arrived, if they had launched even if they had launched the EUV first, I think it would have done a lot better. But something more crossover-like, I think, would have done a lot better.
It just had that dork look, It just had that I'm driving a penalty box type look, even though it was a fantastic car that actually was great to drive. And for the time, had crazy mileage.
268.
260 for what was it? It was like 35,000 out
and
the door.
now used, they're $18,000.
The last year and a half it was on sale. The base MSRP was like 26,000 and change. Which
phenomenal.
Which is it's unreasonable.
And GM's not making a dime on those, selling at that price.
Probably not, and I think that's why they discontinued it because the technology was
old tech.
The technology in there was older. It was more expensive than what they're producing now.
I saw a difference between the Bolt motor and the Ultium motor, and it was the amount of man hours on the copper windings in the Bolt motor was insane versus the much simplified, much more efficient, much more powerful, oil cooled Ultium motor. So.
TireRack.com is your place for the best selection of tires from top brands. Always fast and free shipping and multiple convenient installation options. They also stay on the cutting edge of the tire industry. Their world-class tire testing program is Truth Serum for tires. EV-focused tires, products with noise-canceling technology, they've tested it all to help you make the best decision before buying. TireRack.com, the way tire buying should be. Let's get a little spicy. So I want to move into SDV in a little bit, but before that, do you spend much time evaluating or analyzing Tesla?
I mean, as part of the larger market that we're looking at, we look at what Tesla is doing in the context of the larger market, both in terms of some of the vehicle technologies, batteries, what types of batteries they're using, some of the vehicle structure, and looking at overall vehicle cost, propulsion technologies, electronic architecture, SDV, software, as you mentioned, but also, what they've done on the charging infrastructure side. And, in addition to EVs, I also cover ADAS and automated driving systems. So I pay very close attention to what they're doing in that spectrum as well.
Okay, so let's start at some of the earlier things you said. Specifically, let's talk about Cybertruck. So I don't know if you caught. There's this guy WhistlinDiesel out there who just literally destroyed. He did a bunch of sort of very expensive, destructive testing of a Cybertruck alongside an F-150 Lightning, including he drove the Cybertruck down a bunch of concrete pipes and bashed the back end, and then in a highly viral piece of footage, you could see he rips the whole back end of the truck off, which I assume is the mega casting from the back end, right? So giga casting, whatever,
large scale
casting. So thoughts on that, on whatever failure that does or does not represent, because there's some comparisons like, well, that's aluminum versus steel. That's a fundamentally sort of a body on frame Lightning traditional pickup truck manufacturing versus this new age manufacturing involving mega casting, and then just overall thoughts on Cybertruck.
Yeah, so in terms of what they did, you mentioned that it went over these steel or these concrete culverts, and before that they ripped the bumper off. There was a segment where you could see where it was, as it was coming off there, it whacked that back end, that overhang on the rear end of the truck, and almost certainly fractured that casting at that point, and at the very least weakened it. Right. So that by the time they got around to the next thing where he was trying to tow the Lightning off the it was the Lightning got stuck because it didn't have enough ground clearance. It got grounded on those culverts, and so he's trying to pull it off, and because he almost certainly damaged that casting, it weakened it to the point where trying to tow the Lightning, it just ripped the casting apart. One of the things, while that does not necessarily is not representative of how safe or structurally sound the Cybertruck design is, it does actually highlight something else that's very important.
That some little pitcher can buy $200,000 worth of trucks, destroy them, and make a profit on YouTube.
There's that too, but also I think one of the reasons why Tesla abandoned their $25,000 car program, a lot of what they were trying to do to get down to this low cost point, and what a lot of other automakers have been looking at, is really trying to simplify the assembly process of the vehicle by reducing the number of parts. Instead of having hundreds or thousands of stamped pieces that you weld together or bond together, reducing it down to a few large components, doing a lot of integration with these mega castings, these large scale castings. And that actually works really well in terms of reducing the assembly cost and simplifying the assembly. But the downside of it is that it becomes unrepairable. Right. If you get into a crash, with the stampings, it's designed to deform in certain ways. There's things you can straighten out. There's parts you can take off and replace when you get into a crash. With these large-scale castings, they will fracture instead of bending. And that's what we saw with the WhistlinDiesel truck.
Because they're so large, they...
it's also the nature of a cast part versus a stamped or extruded part. Right. So the downside is, yes, you may get a vehicle that is cheaper to buy, but the flip side is insurance companies are looking at this. If this gets into a crash, we can't fix it. Right. We total it, and so what you end up with is much higher insurance premiums. And we're seeing this with Cybertrucks. A lot of insurers are just refusing to insure them because of repairability concerns. And it's actually true also of some other Tesla models where it's very hard to insure them, or the insurance premiums are very high. And so manufacturers are going to have to take a very close look at how they're taking cost out, because you still have to consider total cost of ownership of the vehicle.
Right. And I think it's the material that it's made of too, right? That, which is, I think it's unfortunate, and I'm not trying to defend, Tesla in any way, but this puts them the virality of this video puts them at a huge disadvantage because a whole bunch of people have seen it. That's all they're going to talk about. Nothing on the internet is ever forgotten. But that's fundamentally an unfair test. No manufacturer has put their vehicle through that kind of test. Now, it does speak fairly well of a traditional steel body on frame truck, right? Because
you could drop it.
They're designed to be extremely durable
Right.
for all these various use cases.
right. I remember, because I'm a huge Toyota dork in terms of like Land Cruisers and Hilux trucks. You know, people ask like, Toyota used to sell a Hilux pickup truck in the U.S. It was just called the original, the OG Toyota truck. That was fundamentally the Hilux sold around the world, and then they branched off and they did Tacoma, right? And the rationale, apparently the internal corporate rationale is, Hilux is meant for third world and second world countries, and for the repairs to be done with a sledgehammer.
Yeah.
Tacoma, you would unbolt pieces.
You go to a body shop.
You go to a body
Yeah,
shop.
yeah.
So it's different levels of durability based on right tool, right job. So then, that was great. Thank you. What are your overall thoughts on Cybertruck coming to market? Did you ever think it would? When you saw the reveal back in whatever it was, 2019.
Yeah.
Did you ever think you would actually see one on the streets? And
And
now
did you
that
put
you
it
do, what are your
And did you put a deposit down?
I did not put a deposit down. I looked at that thing. I mean, there's a reason why trucks are shaped the way they are.
Right.
Because trucks are, fundamentally utilitarian vehicles, and they've evolved over 100 years into this particular shape. Whether you're talking a Maverick or a Santa Cruz or a Super Duty or Ram HD, they have a particular shape because that is the shape that works for the job that they are intended to do. The Cybertruck does not emulate that shape, and while it can be very functional in a lot of ways for what a lot of truck buyers buy. It's not the right shape. You can't reach over and grab stuff out of the bed.
That seems to be, to me, the crazy part.
Yeah.
Like, as a pickup truck owner, I do a lot of that.
Yeah, and most truck owners do.
Yeah,
I mean, they
you
put
actually-
stuff in the bed. They want to grab stuff out of the bed.
Even something as simple as like, the kid fell in the mud. You take the muddy clothes off, you throw them in the bed, 'cause
Yeah.
you can hose it out, and now you have to climb as a rapidly approaching 50-year-old, almost 50-year-old. And now if I had a Cybertruck, I have to climb in and retrieve
Let
the
me
muddy
let me
shorts.
challenge you though, because I'll tell you
Why?
the full size, the modern full size pickup
They-
truck. It's you. None
yeah.
of you
No.
guys.
Hang on.
Your truck you can because it's not a full size pickup truck.
Even on a full-size truck, you can quickly jump on the tire. Most people can jump on the tire and reach in and grab something
Yeah.
small out, but you can't do that with a Cybertruck because it's half a wedge at you.
No, but you're right, Ed. In terms of full size trucks have gotten so big and
Right.
often so tall because a lot of them have off road packages.
Yeah.
So it is more challenging, but nonetheless, like especially for commercial users, they're often upfitting them with various racks and things like
Right.
that. And again, that's not something you can practically do with a Cybertruck. The other part of the Cybertruck that annoys me, I mean, design, visual aesthetics is obviously a matter of personal taste. I don't like it.
I
Some
would
people
just,
do.
Real quick, if I can interject, though, what is great about the design is name another vehicle released in the last decade or so that every single human on Earth has an opinion about, one way or the other.
yeah.
So it works that way.
Yeah.
It really works.
It does
way.
work. It does
Yeah.
work in that respect.
Yeah.
But one of the things that as an analyst, former engineer, going back to the beginning of my career, that I've always been really concerned about is safety. And while the Cybertruck it's unclear actually how good its occupant protection is because of the way it's built. Its ability to absorb energy in a crash is debatable. We don't really know yet because nobody's done any independent crash tests.
They won't. Well, they
But-
probably won't do any.
Right.
Yeah.
But the other part of that is, if you look at safety across the board, over the last decade, we've actually reversed course in terms of the number of people dying on the roads. Almost all of that increase is not from vehicle occupants. Vehicle occupant deaths have gone down. It's pedestrians, cyclists, motorcyclists. And when you take a close look at that Cybertruck, you see these sharp edges, these sharp angles, especially the way they've done the stainless steel panels where they literally just slice them off. You go up and you don't even have to open the frunk and stick your hand in there to slice off your fingers. Just run your thumb along the edge of any of those stainless steel
back
panels.
of the truck is particularly sharp.
Yes, so that. If you when you have an impact between one of those vehicles and a pedestrian or a cyclist, the impact on the effect on the human is going to be far worse than almost any other vehicle.
And remember, America, unlike Europe, we have no pedestrian safety standards whatsoever.
Which is why you'll never see that vehicle sold officially in Europe.
But isn't the issue actually that's causing the rise in the pedestrian and cyclist deaths, right?
If you're listening, Ed pulled a phone out of his pocket.
Both the people not paying attention while driving.
Instagram right now.
They're checking. You're checking your phone while you're driving, and also the people walking through the crosswalk like this and not paying attention.
That is certainly a factor. It's by no means the only factor. I think the other factor is dramatically reduced visibility. You mentioned how big trucks have gotten so much bigger, but especially taller.
Yeah.
And you look at a lot of the newer generations of pickup trucks and full size utilities.
I was looking
they
at
have a much taller hood.
I was looking at an Escalade yesterday. I was like, that is so big.
It's
so
very
big.
easy. Like if there's graphics out there showing the number of kids that standing from the front of one of these trucks, how far out they have to stand from that truck before you can see them from the driver's seat. Right. So even if you're not messing around with your phone, if you're just looking out, you can't see nearly as much out of these vehicles as you could in the past.
Right.
Okay.
Right. Switching gears, NACS. So before Ed got
North
here,
American Charging Standard.
Yeah, the Tesla charger.
SAEJ 3400.
Ooh,
I like that.
Nerd. Sam had done a little bit of spy work, and he was saying that like some upcoming Kia Hyundai vehicles might have NACS very soon. And I did a little spy work, and Lucid saying maybe they might be the first non-Tesla vehicle to have NACS. Is it a good idea to switch to NACS right now? And I'm asking that because like Elon Musk famously just fired the entire department, and it might be a better technology or whatever. That's debatable. But like, what if he just shuts it down? Like, is this a person you want to pin your automakers thinking 4-year chunks? Like, do you want to stick these charging ports on where it might? Who knows what's going to happen?
So I think there's two parts to that question.
Thank you.
The first part, with respect to Elon and firing the supercharger team, is do you want to pin your hopes on the Tesla supercharger network? That, I would say, to your question, you probably don't want to be too dependent on that. That
especially because look, Elon is like become the spokeshole for the anti-EV side. It's the craziest thing in the world. But
why? But why? What were you saying about why wouldn't you want to pin it on the supercharger network, which seems quite robust?
Well, the network is quite robust today, but when you look at a lot of the problems that we have with chargers, a lot of it comes down to software issues. Because unlike the old days, when you pull up to a gas pump, the gas pump doesn't care what the car is. As long as the nozzle fits in the hole, you squeeze, and the fuel will flow at whatever rate, and it doesn't matter. There's no communication between the vehicle and the gas pump. With a charger, the charger has to talk to the vehicle, and they're constantly talking back and forth to each other. Vehicles sharing, okay, what's my current state of charge? How much charge can I accept right now? And so it's all moderating all of that in real time.
And that's a lot of that's for safety.
Yes, absolutely.
People say, why can't it just be like you plug it into a wall and you get 110?
Well, you probably saw what happened in Mexico last week. Some guy plugged in his Tesla directly to the grid.
Onto a 440. Yeah.
So for safety and
so you're
for
saying
durability.
Illegal charging at twice the limit is bad.
Yes.
Okay.
So because of the fact that the charger and the vehicle have to talk to each other, there's a lot of software handshaking that has to go on. Okay. And this is, even though Tesla's chargers tend to be more reliable, Tesla is, up until now, has been in a similar position to Apple, where Apple makes all their hardware, they make all their software, and relative to Android or Windows, they don't have to worry about their software working on anybody else's hardware. They can optimize it, and they've got a limited set of hardware, a limited set of software, and it all works smoothly together. Microsoft or Google with Windows and Android, they have to make their stuff work with thousands of different devices, millions of different devices, with CPUs and memory chips and everything else from all kinds of different companies. The same thing is true on the CCS side of the business. as Tesla opens up their network to non-Tesla vehicles, now they have to make sure that the software in their chargers works with the software
With
in
Ford,
the vehicle, with
with
Ford and Rivian,
GM,
General
whoever.
Motors, and
Yeah,
Hyundai,
yeah,
and Kia, and
But
everybody else.
The onus is on Tesla for that, or is it on the
Well, it's on
OEM
both.
that's switching?
It's on both.
Okay.
You know, there has to be a cooperation there. You know, to test it. You know, to verify it.
So in other words, this is why Ford went first, is because the Ford software on the Tesla end was done first. They couldn't. They're not
Yeah.
gonna. They didn't want to roll everything out. You had to. Okay, the Ford stuff's out, works. Now we're going to program the Rivian end of the Tesla supercharger
and do the testing and verify that it all works smoothly and reliably.
right.
You know, and then when
But then they fired the
when-
whole team.
Yeah, and this is why, for example, GM has not rolled their stuff out yet, because they call Tesla and say, okay, we need to test this and verify this, and there's nobody there answering the phone.
Yeah, I heard
know?
this story. I also heard that people in Germany were like having meetings, like, "Are we really doing this?
Yeah.
Like, are we really switching to NACS?" Like,
Yeah, but now let's look at the other side of the question, which is the port itself, the connector
right,
and the port.
right.
That is really independent of working with Tesla and the supercharger network.
Because it's an ISO
They're-
standard.
Right. Yeah. And so now they've the connector design, the port design has been opened up. It was the SAE formed a working group. They incorporated that into a new standard, an industry standard, and there's lots of good reasons, whether the supercharger network is shut down tomorrow or not, to move forward with using that connector. It's a better user experience.
So for sure. So the what's it going to be called? Ionica, the
Ionna.
Alliance?
Ionna.
Ionna. Sorry, great name. Ionna. There's no reason for them not to roll out NACS.
Absolutely.
Okay.
Yeah, and they've already said they will.
Okay.
Yeah.
Okay. And they said they're doing both, right? Parallel. Okay.
Yeah. And it'll probably be a lot like what we've seen, with Electrify America, where they rolled out predominantly CCS, but at every one of their locations, or almost every one of their locations, there's at least one
Chatamo or
Chatamo port there as well.
Yes. Sadly, charging a first gen Leaf, but yes.
Yeah, but even the second gen Leaf.
Yeah. No, I just wouldn't
Or-
mind.
and
I
maybe
drive by one every
maybe
day.
even the occasional Outlander plug-in hybrid.
Yeah. Yeah. Okay. So where is Ionna? Where is Ionna?
So it was announced about roughly a year ago. I think in March or April of this year, they officially got regulatory approval to form this joint venture. Because there's some antitrust concerns, but the joint venture was launched. The company they're working on their first stations. They have said publicly that they expect to have their first stations operational by the end of this year. Sometime this year.
I would just say, like, again, I don't really know what a Ionna station's going to look like, but I know what like Tesla stations look like, and I've seen them go in like a weekend. Like, why aren't they? Why not rush this? Like, like?
It's expensive.
Well, they have a lot of money. It's like 7 multi-billion-dollar
BMW,
international
GM,
corporations.
Honda, Hyundai, Kia, Mercedes-Benz, Stellantis, and Toyota.
Yeah. Toyota alone has more money than God.
As you said, DC chargers are expensive. Depending on the power levels, they can range anywhere from $75,000 to $250,000 per charger.
Yes.
Yeah.
And you have to deal with the local Joes.
Well, and therein lies the problem. You have a DC charging station that has 10, 12, 20, 350 kilowatt chargers.
Right.
That's a lot of power that needs to go in there. So you've got to find sites that have that power level available, which is not trivial. And that's one of the things my company does. They work with charging providers.
That's the consulting.
The consulting side,
Yeah.
and so because we do a lot of work with utilities too, and so we've got data on where the power is. But there's other pieces. Even now you found a site with power. You've got to negotiate with the site owner, for a lease for the site. You've got to do permitting. You've got to do the engineering design.
So it can't be a quick thing.
So the actual construction, that can go fairly quickly. It's all the other stuff that happens around that. If you have a site that you want to use or need to use that doesn't have enough power and you need a substation upgrade, now you're talking really long times.
Yep.
And interestingly, we were doing a project earlier this year, and from the research, one of the things we found out is that if you want a substation upgrade, right now charging stations are basically like third in line because during the pandemic we had shortages of manufacturing transformers. Now they're manufacturing the transformers, but the priority, the biggest demand
AI.
is high performance
Yes.
data centers,
I hear
and
that.
then healthcare facilities are next.
I hear they're putting coal plants back online to power Google searches.
Yeah.
Like
So,
idiotic. Yeah.
so it can
Yeah.
it can take a while. So one of the things you're increasingly seeing is charging operators looking at battery supported solutions, so they don't have to have as much continuous power that comes in.
Sure.
Have a big local energy storage system or battery integrated chargers. Like a couple of different companies. Deere's got a subsidiary called Chrysler. There's Flow is doing some. Joule is doing these. So there's a few different solutions that are incorporating batteries to support it.
Sure.
So that the batteries provide that peak power demand.
Right. Okay. There's a lot there, and I'm conscious we're going to run out of time before we run out of topics to talk to you about. So I want to talk to you about SDV. Okay.
Oh.
So you talked about Tesla. We talked about charging Cybertruck in particular, but let's focus on software-defined vehicles. Tesla was the first to achieve a scale like volume selling vehicle, the Model S. Are they still the leader, do you think, in software in the software-defined vehicle space? Globally, because I want to talk about China.
I don't think so.
Really?
I think others have caught up. Not necessarily the legacy automakers. They're still having some struggles, but I think certainly a lot of the other startups. Rivian is, I would say, they're probably on a par with Tesla in terms of that. Because of their architecture, and a lot of the Chinese startups. And I think where the startups have an advantage is working from a greenfield. They don't have legacy architectures that they're trying to upgrade or replace,
Right.
and
we
support.
could save a little bit of money by using this Johnson Control air conditioner.
Yeah.
But it doesn't really talk to the, So.
Well, also, they've got products in market
Yeah.
that need to be supported,
ice-
and
their
so
whole
it takes
ice
a,
chains,
takes a lot
yeah.
of resources there to do that.
So let me just for the total layman, why is a software defined vehicle better for the average person than a hardware defined vehicle?
So, my background, I started my career as an engineer. I spent 17 years working as an engineer, working largely on software, electronic control systems for vehicles like anti-lock brakes, early stability control systems, traction control, brake-by-wire. And, up until the last decade, up until the Model S debuted, and even today for most vehicles, the way we've been putting software in cars for 50 years. This is not a new phenomenon. But the way it was done is each time you developed a feature, supplier would sell a feature to an automaker that you'd get a kit that has a bunch of sensors, a bunch of actuators, and an electronic control unit, an ECU with some embedded software. And that software was because those ECUs were generally using the lowest power consuming, the lowest performing chips they could get away with for that particular feature. The software was very efficiently written specifically for that hardware, and it was not designed to be upgraded. So when you had job one for a model program, if you go back 4 or 6 weeks from there, and the software had to be done at that point, and the expectation was you put that software in that vehicle, it does not change for the next 10, 15, 20, 30 years that car's on the road.
Right.
I've got a 35-year-old Miata in my garage, but the only electronic control in there is the engine management system, and it's still got the same software it had when that car rolled off the line in Japan in October of 1989. Right. For what Tesla did was they flipped that on its ear, and instead of having all these discrete ECUs, every time you add a feature, you add a new ECU with its own software. They said, okay, we're going to do fewer ECUs, more powerful compute in there, and we're going to design it so you can update that software, and most importantly, update that software over the air using the cellular data connection. Originally 3G, then 4G. Now a lot of OEMs are doing 5G. So that instead of when you want to make a software update, and in the past there were software updates that were done to vehicles for compliance recalls usually. Right. You'd have to take that car into the dealer, and the technician would plug in a tool
to a modem.
Download it through a modem, and plug in the diagnostic tool and reflash that one specific ECU with new software.
Yeah.
Now you can do that over the air just like you do your phone.
And so the advantage, though, is that like I remember, I think it was the generation ago 7 Series. They were like almost bragging. We said this on the
No,
podcast.
they do brag. They used to brag.
We had over 100 ECUs, and it's like, well, you could get away with like 7 if you really wanted to. And
Yeah.
so it's just, yeah.
But those ECUs were all running tiny little low-power microcontrollers
Right.
instead of NVIDIA
and
Orins
how
and
many-
Qualcomm Snapdragons.
Well, it's what I heard from the Bosch guys, which was that they were saying, well, actually, I heard this from an unnamed top executive at Lucid. It used to be the suppliers, they were in the hardware game, so they're trying to sell you the hardware, and the software was free, and as he added, and it was crap.
Yeah.
Like, but to your, but you're explaining it totally different.
It was inherently limited by the
Yes.
hardware.
Yes.
But
And,
so
I mean, just to give you a quick example, beginning of my career, early '90s, we were doing ABS on an Intel 80C196 microcontroller. So this was a derivative of an 8086 CPU.
Your PC.
Yeah.
Yeah.
It had 12 kilobytes of ROM.
that's 4 times as much as went to the moon.
Yeah, and 64 bytes, not kilobytes, 64 bytes of RAM.
Oh wow!
And
Yeah.
so, the code we were writing for that was all written in assembly language, because that's the only thing that would run on with that little ROM and RAM. And instead of multiplies and divides in the algorithms, we did shift left, shift right, because it was more efficient. It took less code space and it was run way faster. Today, you're writing stuff in some cases in C, but in Rust and R and all kinds of other modern languages. And the cost of ROM and RAM and compute has come down so much since those days.
Right.
On one particular program, that was launching in 1984, we were so close to the limit, and we had to add this additional feature in that it was Opel that wanted an electronic brake force distribution system. We developed the first one of those, and we could not fit it into that 12K part. We spent weeks tweaking the code line by line, trying to reduce it down. We got within about 10 bytes, but we just couldn't get it within 12K. And so we ultimately had to make the decision to go to the next part up, a 16K part, just to fit that in there. That's the way we had to work in those days, because that's what was available.
Right.
Today, you've got these high-performance SoCs, and you've
Systems
got
on a chip.
Yeah, and you've got hundreds of upwards of 100 million lines of code.
And so, how many different on a typical, let's say, hardware-defined vehicle? How many different languages would be running at any one time?
It would be multiple. I mean, most of the stuff that we were running, would be running in whatever assembly language for the particular microcontroller. It could be Intel assembly, could be a Motorola, or whatever.
Bosch,
depends on
whatever.
depends on the chip you're running, but usually some assembly language. So very low level machine language. And then some stuff, some like things like some of the engine management systems, things like that, might be written in C. By the end of the 90s, we had transitioned to ARM chips, and we were writing in C. And now they've gone way beyond that.
We had a guy from ARM on here. So part of the podcast, and this is great. I love this so much, but I want to pause and just update the audience, because you covered a ton very quickly. You're fundamentally talking about the old days with all these different ECUs. That was domain. That's what we considered like domain control, right?
Mm-hmm.
Like this is a ECU, some wires, actuators for, call it the window switch, and then you'd have a separate domain for the windshield wiper, and a separate one even for the dome light,
Seat recliner.
seat recliner, right?
Yeah.
What we're moving towards is zonal architecture, which is instead of each individual domain, each individual feature in the car having an ECU and a bunch of wires and a bunch of actuators, now it's like, hey, all the stuff in the front of the car, all the stuff on the dash, that's a zone, or in cabin, and then the rear of the car, these could be handled by not like one per se, but a couple
Or one.
much more powerful chips. And because we asked this of RJ, you actually, the end goal isn't like one supercomputer in the car, because then you actually have a problem of
You got to run wires to every single device. So
Right.
If you have a few, out at the edge of the vehicle, I mean, literally, physically located near the edge, so in the front corners, the back corner, you can have short runs of wire to all the various sensors and actuators and lights and things like that, physically close.
Yeah, quadrants. You bust it up into quadrants.
Yeah, so you have hence the zonal thing. So you have these zone controllers that handle some basic functions like power distribution to all these devices, and also getting the raw signals from those devices and doing some basic signal processing, and then feeding that into an Ethernet network that is a simple Ethernet network that's going back to that central compute box. The Rivian's a great example. That central compute box has two main boards in it. One of them has two NVIDIA Orons on it. That handles basically all the chassis control, so your propulsion system, your ADAS, driving functions, steering, all that stuff. And then the second one is running a Qualcomm Snapdragon cockpit processor. That's handling your screens, all your instrument clusters,
Unreal Engine,
the Unreal Engine, a lot of the body control stuff. And then you've got the battery management system, which is sitting on the pack, which is handling that stuff. Mm-hmm. So you don't necessarily want to just have one box because, as you said, the wiring would get too complex. So you want kind of the, kind of a spider web sort of thing.
And if you're listening at home, this is like one of the.
This is worth $5 billion to Volkswagen too.
Yes. Mm-hmm. Well, one of the reasons why software-defined vehicles are called that is because they're defined by the software that runs on them and the fact that it can be updated over time and bring in new features. So, and I think again, we talk a lot about Tesla, how it was the first. Things like adding fart mode later on, or adding the Christmas, the holiday ability for the vehicles to dance and things. That is fundamentally impossible to do in most modern vehicles today because they aren't able to. You can't go tell the lights, "Hey, lights, we're going to upload a program, which means you're going to alternate the way you flash to music while the doors also open up and the inside the screens go crazy and showcase and play some holiday music." Like these are new features that theoretically make the products better over time that being software defined enables.
Yeah, and the old stuff, as I said, is fundamentally limited by the hardware, the microcontrollers that you're running. Now you've kind of decoupled the software from that underlying electronic hardware. You've given it so much capability, so much compute capability, that now you can, and that it is controlling a whole bunch of things. Now you can build a bunch of applications, and in a lot of ways, that software platform is very analogous to what you get with something like Android or iOS, where you're building the applications, the apps on top of that you've got an app that does your stability control. You've got an app that manages your lights. Instead of having an ECU that, when you've got sequential turn signals, that's doing that, or, like on a Rivian, when you plug it into charge and the light bar across the front is giving you an indication of the state of charge. Right. You can just write an application that is sitting on top of this abstraction layer that then talks to the hardware. So now you can change the hardware independently of the software and vice versa.
So like another way to put it is like Apple iOS came out, TikTok wasn't invented until 7 years later.
Yes.
So in other words, the killer apps of the future that are going to run on these systems haven't been invented yet, but on non-software-defined vehicles, you can never get those apps on board. It's like your old Motorola phone.
You don't have the headroom. You don't have the capacity to do it.
Yeah.
Okay.
All right, hey, switching CEOs for a second here. This is the one where all my kind of car enthusiast friends are freaking out about. Akio Toyoda, he said, apparently said, I never saw the quote, but instead of building one EV, you could take all that lithium and build, 9 billion hybrids, and that's better for the environment. We really haven't talked about decarbonizing
it's
at all.
Four. It's one EV can be 4 plug-in hybrids.
It was more than 4.
I think it's 1960.
1960, yes.
Or 1690.
Yeah. What do you think of that quote as an analyst?
The math works. He from a completely rational perspective, he's absolutely right. That a typical hybrid has a battery that's somewhere between 1 and 1.5 kilowatt hours. A typical average EV in North America today is somewhere. On average, it's about 90. Because we've got a lot that are upwards of 100.
80 to 100. Yeah.
Yeah. It ranges from anywhere from 60 to 200 plus.
212.
Yeah. So, but on average, it's somewhere around 90, between 90 and 100. So, if you've got a 90 kilowatt hour battery pack, the materials that went into that battery pack can build 90 hybrids for relative to one EV or 6 plug-in hybrids. So that math works out. And actually, if you put 90 hybrids on the road, if you put 90 Priuses that get 50 miles per gallon on the road, you are going to have much more environmental impact than you have from a single BEV. Right. So, today, because of the cost of the materials and the environmental impact of the materials, it actually does make sense for most people right now to go drive a hybrid, and in some cases a plug-in hybrid, than it does for them to buy a BEV. Long term, that equation is going to flip as the costs continue to come down, and as people get comfortable, as the charging infrastructure improves, and people get comfortable with the idea of driving a BEV and figure out how and when to charge it, then that will eventually flip. And that's why earlier on I said, inevitably, BEVs will be the right solution.
But isn't it also a very convenient thing for Akio to
For the
say,
number one hybrid?
given the weakness of the Toyota lineup in terms of battery electrics? Yeah. I mean, do you agree?
No, you're absolutely right. It is convenient, but that doesn't mean it's not true.
Sure. Discover the best off-road trails with OnX Off-Road, the ultimate GPS navigation app for adventurers. With OnX Off-Road, you can find open trails near you, even without cell service. Unlike Google, OnX has real humans mapping trails, providing detailed information on trail difficulty, descriptions, pictures, and more. Whether you're looking for rock crawling areas or checking if your trailer can make it to a dispersed camping location, OnX Off-Road has you covered. Plus, you can explore both public lands and private properties confidently. Start your adventure with a 7-day free trial and experience the difference. Download OnX Off-Road today and elevate your off-roading experience.
Yeah.
In that vein, because I've asked this of a couple other guests, and that you're the perfect person to ask, who are you concerned about for the future of mobility, that they're not going to make it, right? I tell people all the time, right? This is you have to be a fan.
And if it's Nissan, just blink twice.
You're not a real car fan if you're not like grabbing a bucket of popcorn and watching how crazy this stuff is going on in China. All these legacy manufacturers here scrambling to try to adjust their product lines.
The Fisters and Faraday Futures.
Yeah,
of the world.
all these wild startups chasing Tesla, but I brought them up a number of times. Like, I'm super concerned. I love Mazda. I'm super concerned about Mazda. Is there anyone else on your list that
what's your list?
They're not going to be around in 5-10 years.
I think there's a bunch of brands that I don't think will be around. Mazda, I think, is one that is very much at risk.
Writing this down.
But
dead.
a lot will. I didn't say dead.
Well, won't be around and dead are kind of synonyms.
Okay. I think small to medium-sized brands, especially if they're trying to go it alone. I think what we're going to see is a lot more consolidation. Some of the brands will go away. Some of them may exist within a larger group, as a niche within that group. But they're gonna have to depend a lot on sharing of components and resources with other brands.
What's stopping Mazda?
Hey, who else?
Oh, you want?
I think certainly, Stellantis having 14 brands does not make sense. Sure. There's a bunch of Stellantis brands that are at risk. Here in North America, certainly Chrysler is.
Well, Chrysler's down to a vehicle at the moment.
Right, and they've talked, about expanding adding a bunch of new models, and I think a lot will depend on the success of some of these first batch of EVs that they're launching with Dodge and with Ram and Jeep, but I remain skeptical that they will find a place for Stellantis in the lineup.
Okay, Mazda, Stellantis, any other Japanese brands?
Let's see. You mentioned Nissan. They were a pioneer in bringing mainstream EVs to the market, but they have done very little since then. We've got the Aria now. They've got some other EVs in other markets, and they've shown us. Like last year, I went to Tokyo for the Japan Mobility Show and visited their design center. We saw a whole bunch of stuff that they're working on that was supposed to be launching over the next 4 years. None of those have arrived yet. Some of those may not. A significant number of those may not arrive. We'll see. They're very much on the bubble. Oh. And then there's also a lot of startups. Certainly a lot of the Chinese startups. I think you mentioned earlier on, Most of them have never made money, and probably never will make money. That right now it's estimated in China there's production capacity for about 40 million vehicles a year, and it's a market of about 28 million vehicles a year, and those vehicles got to go somewhere. So there's I think a lot of the Chinese brands will go away, while others will grow and become. It'll be like it was here in the early 20th century, where we had hundreds or thousands of automakers, and it gradually consolidated down, to three. It'll probably be more than that in China, but there will be a lot fewer than there are today.
How about Lucid and Rivian?
Rivian, I have a lot more confidence in now than I did 2 months ago, because of the deal with Volkswagen
and the deal with XPeng.
Yes, right? As well. Yeah. So I think they're probably going to be okay. Lucid is an interesting situation because of their ownership structure. I think something like close to 90% of their shares are owned by Saudi Arabia, the PIF, and various other Saudis, and at least near term, I think they'll probably be okay, because I think their owners don't want to see it fail, and so I think that there will be some near term patience. I think a lot's going to depend on how successful the Gravity and then whatever the midsize vehicle is. If those start to gain some market traction and they start to grow, then they'll be okay.
Well, the question I was trying to ask before.
One other one that I want to highlight is, particularly after post VW Rivian deal, is Scout. VW, you got Rivian. Scout is a 100% direct competitor 100%. To what Rivian does.
We think they still haven't shown a damn product.
Well, they've shown sketches. They've shown sketches of a pickup truck and an SUV
4 years ago.
And the way they've talked about it, as a lifestyle, outdoor, off-road brand. And that's what Scout always was. It's kind of that.
Well, there was semi-truck maker, but
yeah. But so does is there, by the time Scout arrives in 27, 28, 29, whatever, is there still a place for them in the market, or has between Rivian and Jeep and maybe Ford and maybe Toyota, have they absorbed that market for off-road vehicles? Probably. Right. And so I would not be shocked to see VW say, we worked on this, we think by the time we're ready, it's going to be too late, and there's not going to be enough space in the market, and it doesn't make sense to add yet another brand.
Oh, interesting. Well, I was going to say, like Mazda, what would stop them, the way Aston Martin has done, from just licensing Lucid's technology? They might have to wait a couple years for that midsize stuff to come out, but like we were talking about with skipping, the poor nations skipping over analog cell networks. Just buy the best technology, because you say what you want about Lucid, business model, whatever. Their battery management tech and their motors are the best in the business by almost a generation. And they're already licensing it. So if you were Mazda, wouldn't that be something you'd think about? Or a Mazda-like brand?
Yeah, and I think we will see a lot more technology licensing across the industry, and even if some of the smaller brands, the weaker brands, survive, and I think that if they do survive, the way it will be is through these these technology sharing partnerships, because a lot of the underlying technology that we're talking about, whether it's batteries, propulsion systems, electronic architectures, even the core software platform, these are not consumer-facing things.
Right.
The consumer doesn't care who made the motor that's in an EV or who made the batteries, as long as it works. Right. What the user experience is what the consumers are going to, especially with software-defined vehicles, is what they're going to experience. That's going to be the product differentiator.
Right.
And so it makes no sense for Mazda to develop their own motors, their own battery packs. They should be partnering with somebody else, whether that's Lucid or Toyota, which they already have an existing relationship with, and same with Subaru is another one. A lot of these brands. And even with larger brands, I think we will see consolidation of a lot of the core hardware that is not consumer facing.
Marchioni's dream of one engine.
Yeah, no, exactly. Well, right. As an example, Geely Group. They own Volvo and Polestar and
Lotus,
Zeekr and a whole Lotus. And several years ago, they took the powertrain division from Volvo cars and combined it with powertrains from other Geely Group brands and put it into a new company that's part of the Geely group. And so you've got this one business unit that's developing powertrains for everything within the Geely group.
Right.
And we'll see the same thing going on the electrification side, software and electronics.
I'm glad you brought that up because we're going to finish because we're pretty close to time here on China on and a multi-part question that will take another 45 minutes for you to answer, which is okay.
So make it a soundbite.
Where's Eisenstein hiding?
So
I know he's around here somewhere.
So
That's some inside baseball,
Yes.
folks. That's some real inside baseball.
I can't believe you brought it up.
How dare you? Cut that part.
China now.
No,
there's a 100% tariff on anybody thinking about bringing a Chinese vehicle into this country. Chinese software looks to be a ban on Chinese software in vehicles coming to the U.S. Also
Almost inevitable.
It's almost inevitable, right? Seems to be coming.
I'm learning.
But when
That's like almost perfect. But yeah, go ahead.
when will Chinese EVs come? And
Will they come?
Will they come? And will Americans buy them? And why? Because I think you've had a lot of experience, or hopefully you've driven some of these Chinese EVs, but everybody seems to think it's for all this digital stuff that's coming, karaoke and the great in-car AI assistance and all this stuff. But are Chinese EVs going to come when, and will Americans buy them?
So, I mean, we've already got some Chinese manufactured vehicles here. There is a Chinese EV here, the Polestar 2.
Buick also has a couple.
Buick
Not
has
an EV.
not an EV. They have the Envision, which is internal combustion. The Polestar 4, at least initially, is being sourced from China. That goes on sale this fall. Last week, Thomas Engelauth said, "Yep, we're still going to launch it this fall and get it from China." And it sounds like
supposedly the Lotus SUV if it ever shows up.
yeah, Geely, Geely is basically going to eat the tariff on the Polestar 4 until they get production out of South Korea next year.
And the little EX30, the Volvo.
Yeah,
is
that
Chinese,
one
right?
they've decided to just delay the launch until next year when they can build them in Belgium, and they'll bring those in from Belgium. So that one, the price point of that one is so too low they could not absorb the
100%
tariff
of that would be turn
but-
a $35,000 vehicle into a $70,000.
Yeah, that wouldn't make sense. But for the Polestar 4, they are bringing that from China for now. So there are some, but I think in terms of the Chinese brands, BYD, Zeekr, Li Auto, NIO, I think it's as long as those tariffs are in place, it's going to be really tough for them. Like BYD, the Seagull, the Seal, these are really great cars. And, they sell the Seagulls in Mexico for $11,000, $12,000. In order to make that fully compatible with U.S. safety regs, that's going to add some cost there.
Do you know anything about that real quick? Just to pause it. Do you know anything about, has anyone ever crash tested a Chinese vehicle?
Oh, yeah. They do.
No.
Yes.
Has an American crash testing organization ever crash tested a Chinese vehicle?
Nothing that's been published. Let's put it that way.
Okay.
I'm
That's
pretty
just
sure
my
that
question.
I'm pretty sure that there are automakers that are based here that have bought those vehicles, brought them in, and done their own crash tests on them.
And I should say Chinese market vehicles.
Yes.
I bet the Buick Envision
Yeah,
has
well,
been crash tested. I bet the Polestar has.
Yeah, oh, absolutely. And as an example of the distinction between Chinese market vehicles versus others, last year I toured. There's a company in Livonia, Michigan called CareSoft. And they do teardowns and other stuff, and they had 2 VW Tiguan's there that they had torn down. One was built in China for the Chinese market.
Oh, cool.
The other was built in Germany. That was for the European and North American version. And pre-teardown, they look identical. Once you take them apart, you start to see there's a bunch of differences. There's some braces that are included in the version for Europe and North America to meet certain crash requirements that are not there.
Right.
There's about half as many spot welds in the structure. So that reduces
So this
structural
is
integrity.
why government regulations are good, people. They
Right.
wouldn't do it otherwise.
Right.
Yeah.
And so, for something like the Seagull, to bring it up to U.S. crash test requirements, it would probably, it's probably going to increase the cost, maybe not to $20,000, but probably, at least $17,000 or $18,000, for all the various things that you need to do. Will they eventually bring them here? I think at some point, the Chinese brands probably will try to come into the U.S. market, but right now there's enough barriers, both in terms of trade barriers and other things. And the U.S. market is a very competitive market. You got a lot of brands here already, and there's not a lot of growth. What they're focused on right now is Latin America, Africa, Southeast Asia, where there's a lot
India's
of
the market,
India, where there's a lot more immediate opportunity, low-hanging fruit in terms of markets that are available. And, they'll focus on building those markets first. And then I think maybe towards the end of the decade, we'll start to see them try to.
They did Belt and Road already. So the Belt and Road initiative might as well put the cars on those roads.
Exactly.
No, but I was going to say, the U.S. market is 14 million new cars a year?
It'd be somewhere around 15 and a half this year.
But it's going to be between 14 and 17 million kind of probably for a long time. It has been for a long time.
Yeah, 17 is kind of the peak we've ever hit.
Right. That was 2016 or whatever.
Yeah.
But India, you're looking at another country that could get to 30 million new cars a year potentially.
Yeah, you got 1.5 billion people.
Yeah.
So they got a lot of problems.
Sure, but I mean,
you think our infrastructure bad?
But there's
problems are solvable.
There's a lot. It's a potentially large enough market. There's still a lot of room for growth there.
Right.
Even within the constraints.
In other words, if BYD shows up here, how many cars could they potentially sell if the market cap is 15 million vehicles a year? They're not gonna take a huge slice of that pie. Whereas in India or any developing market, you could really
they will if
X-time it.
As we just talked about, if they put Mazda, half of Stellantis, and other companies out of business based on the sales.
Yeah, but I mean, if you add up Mazda and a few Stellantis brands, you're talking a few 100,000 vehicles.
I know.
So
well, hey, Ram is Ram alone's over 500,000.
Yeah.
So,
Okay. Dang it, we had so many more things to ask you.
Let's get them back.
We'll have you back next time you're in town.
Do 2 in one day. That's the way to do it.
Yes, that'll be the best way to do it. But let me give you some time to plug Guidehouse and wheel bearings. Anything else you wanna plug? Because I know, again, I went to the site. You have some delightful teasers on these reports that Guidehouse offers up. Not to basically you listeners, unless you're deep auto industry folks, but what do you want to tell people about if they want to learn more about you and your work?
Yeah, so if you go to guidehouseinsights.com, you can see all the topics that we cover, all the reports that we've published. You can get our roadmap. The reports that are listed on there are all available for anybody to purchase. Depending on the report format, they go anywhere from about $2,000 to $4,000. So they're not cheap. But if it's an area that you're that you're interested in, you can buy those reports. And we also do custom research. So those are syndicated reports anybody can buy. We also do custom research for clients on a wide variety of topics. So if you don't see what you need in the syndicated stuff, give us a call, reach out to us, and we're happy to have a conversation. So we can do market analysis, do advisory stuff. We can write white papers and all kinds of other stuff. And then Wheel Bearings is the podcast that I do every week with my friends Nicole Wakelin and Roberto Baldwin. And you can find that at wheelbearings.media. You can buy T-shirts like this one at shop.wheelbearings.media.
Nice.
We talk about the cars we're driving and some of the stuff that's going on in the industry and do some interviews. I just recorded several interviews yesterday while I was driving the Volvo EX90 with some folks from Volvo and Qualcomm and others. So lots of interesting stuff there to listen to as well.
Awesome.
So after you listen to The Inevitable,
that's right.
Then
come over and download a year's worth of wheel bearings.
Yeah, we've we've got
buy some T-shirts. Damn it,
we've got 363 episodes in the catalog already.
That's
we've
been doing it for year. Almost. You can listen to wheel bearings.
Yeah, one a day. We've done it for almost 8 years now on a weekly basis. So
amazing. All right. Awesome. Well, Sam, we got to have you back again. I got way more questions.
All right. Absolutely. I'm happy to next time I'm in town.
All right.
Cool.
Thank you.
We'll do it.
The Inevitable Vodcast, brought to you by the all-electric Nissan Ariya. Inspired by the future, designed for the now.